Good morning, everyone. I welcome you all for the course Concrete Technology CE8404. In this video, we are going to see about admixtures.
The term admixture is defined as the material other than water, aggregate, hydraulic cement, and fiber reinforcement used as an ingredient of the cementitious mixture to modify the freshly mixed setting or hardened properties of the concrete. It is added before or during the mixing. Usually, concrete consists of cement, fine aggregate, coarse aggregate, and water. The few other substances added to the concrete to modify its property, such materials are called as admixtures. Why we use admixtures? Usually, admixtures are used to reduce the cost of the concrete, to modify the properties of the fresh and hardened properties of concrete, and it also ensures the quality of the concrete during mixing, transporting, placing, and curing, and also it overcomes certain emergency during the concrete operations. The functions of the admixtures are it increases the workability of the concrete without increasing the water content or decreasing water content at the same workability. It accelerates the setting time of the concrete. It can be used to reduce or prevent the shrinkages during curing. It modifies the rate of bleeding. It reduces segregation, improves the pumpability, and it accelerates the ALH strength of the concrete and increase the flexural, tensile, and compressive strength of the concrete. It also can be used to reduce the permeability of the concrete. Thus, the durability of the concrete can also be improved. It can also increase the bonding, impact, and compression resistance of the concrete. Chemical admixtures. Chemical admixtures are added to the concrete in very small amount, mainly for entrapment of air. It reduces the water content and also control the setting time of the concrete. The commonly used chemical admixtures are air entrapping agent, water reducing or plasticizer, retarders, accelerator, and super plasticizers. Next one is mineral admixtures. Mineral admixtures are usually added in large amount to enhance the fresh and hardened properties of the concrete. It improves the resistance of the concrete to thermal cracking, alkali aggregate expansion, sulfate attack, and also reducing the cement content. The commonly used mineral admixtures are fly ash, silica fume, granulated blast furnace slag, ground granulated blast furnace slag, commonly known as GGBS, and then Metakaoline. Air entrapping agent. An air entrapping agent introduces air in a form of minute bubbles distributed uniformly throughout the cement paste. The main types include salts of the wood resins, animal and vegetable fats, oils, and sulfonated hydrocarbons. Usually, the entrapped air is of size of 5 micron to 18 micron, distributed evenly in the entire mass of the concrete. You can see the air bubbles on the surface of the concrete. This is the microstructure of the concrete containing air bubbles. The major proportion of the commercial products includes abiotic and pymeric acid salts, fatty acid salts, alkali sulfonate, and phenyl ethyl oxalates. The advantage of adding air entrapping agent to the concrete, it includes it reduces the bleeding and segregation of the concrete because the bubbles The advantage of adding air-infiltrating agent in the concrete is that it reduces the bleeding and segregation of the concrete because bubbles act as an extra fine filler attachment with the cement plates and link them. It increases the intermolecular attraction caused by absorption of the air entrainment and also increase the total surface area of the constituents. The water flow between the cement paste is restricted. It also increases the workability of the concrete by ball bearing actions. The next one is water reducing agent, commonly known as Plasticizers. A material which is either increase the workability of the fresh concrete without increasing the water content is termed as water reducing admixtures. As the name implies, the function of this admixture is to reduce the water content of the mix. It usually reduces the water content by 5 to 10%. Thus, the purpose of using water reducing admixture in the concrete is to allow the reduction in the water cement ratio while retaining the desired workability. Generally, during the design mix, we will increase the workability by adding additional water. By using plasticizer, we can maintain same amount of water cement ratio for different mixes. This is the action of water reducing agent. It will increase the workability, that is flow of the concrete. Next one. The commonly used plasticizers are limonsulfonic acid, hydroxyl carbolic acid, naphthalene sulfonic acid, sulfonomethane polycondensation products. Generally, the reduction in water depends upon the dosage of the admixtures, cement content, type of aggregate used. So it is usually a trial and error mix to determine the amount of reduction in water. The water reducing in the concrete is caused due to two effects, that is dispersion effect and retarder effects. First one is dispersion effect. That is, the Portland cement will has a tendency to flocculate in the wet concrete. That is, it will flocculate, form a matrix. Due to formation of this matrix, few amount of water has been entrapped in it. So, if the concrete is defalculated, then the entrapped water can be used for workability. That is the concept, that is dispersion effect. When the cement particle is defalculated, the water trapped inside the concrete get released and now available for the fluidity of the mix. The next one is retarding effect. As I mentioned earlier, the plasticizer get absorbed on the surface of the cement particles and form a thin shell. This will incubate the hydration reaction between the water and the cement. As long as there is a sufficient amount of plasticizer available, it will cause retarder effects. That is, negative will repel each other, which result in the increase in workability. What are the other advantages of adding water reducing or plasticizer? It increases the workability of the concrete without reducing the compressive strength or changing the water content. The high strength can be obtained with the same cement content by reducing the water cement ratio. It helps in saving the quantity of cement up to 10%. See, here we have a reference of the control mix, that is without the usage of plasticizer. When we use Accelerator by small amount, that is 0.2 to 0.3% of water, we can see that the strength of the concrete has been improved. There we can see this increase in strength of concrete as well as the cement content for the same mix. The next one is super plasticizer. As the name include, it can reduce the water content by 30%. At the given water cement ratio, water content in the mix, that is dispersion effect of the super plasticizer, increases the workability of concrete, typically by raising the slump from 75 mm to 200 mm. The resulting concrete can be placed in the congested reinforcement and where the place we cannot do compactions. This slide shows the effect of the superplasticizer. Here we can see the concrete is in some plastic state. Here we can see the effect of the superplasticizer. It is mainly due to the retarding effect, that is dispersion effects. The commonly available superplasticizers are methylene formaldehyde concentrate, modified lymphosulfonate, and other sulfonic acid ester and carbohydrate esters. This is the physical effect of superplasticizer in the paste. Low fluidity we can see, high fluidity, that is defaculated, dispose in less amount of water. The advantages of superplasticizer: it can reduce the content of cement content to greater extent. This will lead to economy. The water cement ratio can significantly reduce without changing the workability. This also reduce to increase in strength. It will cause reduction in permeability, so the durability of the concrete is also improved. Another one is that the early strength development of concrete using the superplasticizer is high. Hence, it can be used in the pre-stressed concrete or casting of floors or precast materials. This slide showing the advantage of superplasticizer over the control mix. Here we can observe there is an increase in strength of concrete during early stages and also reduction in the cement content, where we can have same amount of the compressive strength at later stages. The next one is set retarding, that is, they are commonly known as retarders. It is the chemical admixture which is added to decrease the initial rate of hydration or increase the setting of the concrete. It functions by coating a surface of C3S. We usually know the tricalcium silicate is responsible for the setting of the concrete. So by delaying its action, the setting of the concrete can also be delayed. The reaction products are slow to form, such setting and harden of concrete are delayed during the early compressive. The retarders can delay a setting by 8 to 10 hours. Usually, when we are using a ready-mix concrete, it will take a lot of time for moving it to site. So, in such cases, the workability and the properties of the concrete can be affected. So, in such scenarios, we can use retarders to increase the setting of the concrete. The common ingredients in the retarders are lymphosulfonic acid and their salts, hydrocarboxylic acid, carbohydrate includes sugar, the commonly known retarders. What are the advantages of using retarders? It improves workability, cohesion, and extends the setting time. Hence, it provides protections against delays, stoppages, facilitate the workability of the concrete for extended period. In larger construction, good quality of workability is true. Placing the period and prevention of the cold joints is ensured by adding retarder in the concrete. The extended setting times minimize the risk of long distance delivery in hot weathers, improves the pumpability of the concrete by extending the setting period and improving the workability of the concrete. It also reduces the bleeding and segregation of the concrete. It reduces the adverse environmental effect of various nature on the concrete and embed the steel by considerable reduction in the permeability. This image shows the properties of the concrete over retarders. Here we can see the control mix has an initial setting time of 4.5 hours and 9 hours. While we add retarders, it can increases by, we can see it can increases up to 16 hours and 21 hours. Without but also the compressive strength of the concrete also found to be increases with increasing the dosage of the retarders. The next one is accelerated. The admixtures which are added to concrete to increase the rate of hydration or shorten the setting period are known as accelerators. Here the action of the C3S, that is tricalcium silicate, is increased. Generally, accelerators are used in the precast elements to increase the setting of the concrete. The commonly used materials are alkali hydroxides, silicates, fruitosilicates, organic compounds, calcium formates, calcium nitrate, and sodium chloride and calcium chlorides. The advantage of using accelerator: it shortens the setting period of the time, therefore increase the rate of grain of strength in concrete. It enables the earlier release of precast molds, thus speeding the production process. It also reduces the segregation and increase the density and compressive strength of the concrete. It cures the concrete faster and therefore uniform curing in the winter and summer can be achieved. It reduces water requirement, bleeding, shrinkage and time required for the initial set. This figure we can see that while adding accelerator we can see the workability of the concrete has been increased, and then the strength of the concrete found to be increases with addition of the accelerators. Mineral admixtures are finely divided siliceous material which are added to the concrete in relatively large amount. It ranges from 20 to 70% by the mass of the total cementitious material. The power plants using the coals as a fuel are the major source of these byproducts that are produced at a rate of millions of tons every year in many countries. Dumping of this material into landfills and steam of amounts to waste of material will cause serious environmental pollution. The disposal as a concrete aggregate or for the road-based construction is low value, which not only utilize the pozzolanic and cementitious potential of this material. With the proper quality control, large amount of many industrial byproducts can be incorporated in concrete in a form of blended cements. Whenever a pozzolanic and cementitious byproduct can be used as a partial replacement of cement, it represents a significant amount of cost saving and energy saving. Advantages of using the mineral admixtures: it lowers the rate of the hydration and thermal shrinkages, it increases water tightness, it reduces alkali aggregate reactions. It also improves the workability and lower the cost of the concrete. Pozzolanic reactions. The term pozzolana is the material which has a reactive silica in it. The pozzolana reacts with the calcium hydroxide, forms CHS gel, which is responsible for the compressive strength of the concrete. The concrete which are the mineral admixtures which are commonly used in the concrete are fly ash, GGPS, and generally pozzolana are used as a replacement for the cement. There are two types of pozzolanas, that is naturally available pozzolana and artificially available pozzolanas. Naturally available pozzolanas are the materials that is available on the earth crust. It will be undergo some process to be used as a pozzolana, such as grading, intergraining. The commonly available pozzolanas, natural pozzolanas, are volcanic glasses, volcanic tuff, and calcinated clays. These are the examples of pozzolanas: volcanic glasses, calcinated clays, which is nothing but a clay which is heated at high temperature for 2 hours. Diatomic is an amorphous silica which is composed of the skeletal shell from the sea cell walls of the aquatic materials. It is largely deposited in California. Next one is artificial pozzolanas. Artificial pozzolanas are the byproducts of the factories, which include fly ash, silica fume, risers, metakaoline, and surki. Fly ash. Fly ash is finely divided residue resulting from the combustion of the powdered coal, transported by fume gases and collected by an electrostatic precipitator. The fly ash is most commonly used pozzolana all over the world. The importance and use of the fly ash in the concrete has grown so significant, particularly for making high strength and high performance concrete. Utilization of the fly ash as a supplementary cementitious material is a subject of current interest all over the world. This shows the microstructure of the fly ash. We can see the fly ash consists of several smoothly round-shaped particles. The fly ash are used in the construction of dams. The effect of fly ash on the fresh properties of concrete. By using right quantity of fly ash, it will reduce the water demand for the given slump. With the reduction of unit water content, the bleeding and drying sinkage of the concrete can be reduced. Since the fly ash is not highly reactive, the heat of hydration can also be reduced by replacing the fly ash with the cement. The effect of fly ash on the hardened properties of concrete. The fly ash contribute to the strength of the concrete due to its pozzolanic reaction. However, the pozzolanic reaction proceeds slowly, hence the initial strength of the concrete is lower when compared to the controlled mix without fly ash. Due to the continued pozzolanic activity, the concrete develops a greater strength at a later stage, which exceeds the controlled concrete. The fly ash concrete should be cured for long enough. In this case, fly ash concrete can be used in underwater structures such as dam, which will derive the full benefit of attaining improved longer strength and water tightness. Durability of the concrete. Since sufficiently cured concrete containing good amount of fly ash shows a dense structure, which will has a highly resistivity to the infiltration of the dissoluble materials. It also recognizes that addition of fly ash contribute to reduction in the expansion of the alkali and aggregate reactions. The high volume fly ash is that concrete which has 50 to 60% of fly ash incorporated in it. It was first developed for the mass concreting where low heat of hydration is of main importance. Due to the low water content of the high volume fly ash, use of plasticization became necessary and use of air entering agents are commonly used. The next one is silica fume. Silica fume refers to as microsilica or condensed silica, which is used as another example. Silica fume The next one is silica fume. Silica fume, also referred as microsilica or condensed silica, is another material that is used as an artificial pozzolana in concrete. It is a byproduct resulting from the reduction of high purity quartz with coal in electrolytic arc furnace, the manufacture of silicon or ferrosilicon alloys. Silica fume rises as an oxidized vapor. It cools, condenses and collected in the cloth bags. It is further processed to remove the impurities during its production. The condensed silica is essentially a silicon dioxide in non-crystalline form. This figure shows the silica fume. If we see into the morphology of the silica fumes, it will look as a cohesive material. The influence of silica fume on the fresh properties of concrete. It will increase the water demand in the concrete. Increase in water demand is of range from 1% for every 1% substitution of cement. Therefore, 20 mm size aggregate containing 10 mm silica fume will have an increased water content of about 20 liters per meter cube. The measure has been taken to avoid this increase by adjusting the aggregate grading or using the super plasticizers. The addition of microfill will reduce the slump, but because of its cohesive nature, as we seen in the micro structure of the silica fume, it is found there is a large reduction in bleeding, and concrete with a microsilica can be handled and transported without segregation. It is also reported that the concrete containing microsilica is vulnerable to plastic shrinkage cracks, and therefore sheet or mat curing should be required. The influence of the hardened concrete. The concrete containing microsilica shows an outstanding strength in the development of concrete. It is found that the modulus of elasticity of the silica concrete is less than that of the concrete without silica. The next one is rice husk. Rice husk is obtained by burning the rice husk in controlled manner without causing an environmental pollution. When properly burned rice husk, it has a high amount of silicon dioxide and can be used as an admixture. The rice husk exhibit higher pozzolanic characteristics and contribute to high strength and impermeability of the concrete. In India, about 122 million tons of paddy were cultivated every year. Each ton of paddy produces 40 kg of rice husk ash. This can be used as a potential pozzolanic material to almost give the same amount of microsilicas. It's an image of the rice husk ash. The next one is Shruki. Shruki is the most commonly used pozzolanic material in India. Shruki is an artificial pozzolana made by powdering the bricks or burned clays. In some major works, a large scale of Shruki or clay balls are used or specially burned for these purposes, and they are powdered and used in the concrete. By its nature, it is a complex material differing wide variety in qualities and performance. Because of its constituents like minerals, degree of burning, and fineness of the graining. Because of the complexity of these problems, there is always a much confusion on the account of results obtained by various research workers. This shows the image of Shruki. Shruki, which is burned at higher temperature, forms metacaolines. They are also called as calcinated clay pozzolana. It is used instead of Shurkis. Shruki has been used in the construction of the Bakarangal Dam. The next one is GGBS, which is known as ground granulated blast furnace slag. It is a non-metallic product consisting essentially of silica and alumina of the calcium and other bases. The molten slag is repeatedly chilled by squashing in the water to form a glassy sand like granulated materials. These granulated materials further grounded or intergrinded to less than 45 microns to have a specific surface area of about 400 to 600 meter square by kgs. The performance of the slag largely depends upon its chemical composition, glass content and fineness of graining. The figure shows the image of the GGPS. There are two methods of making the GGPS, that is blast cement. First one, the slag is interground with the cement clinker along with the gypsum. The second one is blast slag can be separately added during the mixing of the concrete. The performance of the GGPS in concrete. The replacement of the cement with slag will reduce the water content to some extent. This reduction in the water content will predominantly due to the increase in the slag content, which depends upon the fineness and grading of the slag. In addition to water reducing, the surface of the slag is slightly slower than the cement. Hence, it reduces the heat of hydration. It refines the pore structure of the concrete. It reduces the permeability